All right. Well, did you fight the law and did the law win on the law of sines? We just had that test, and I'm hoping that you did well in that unit. We're moving on because some people ask me, Miss Cowan, when can we get back to trigonometric identities? We love those things. We love substituting them in and simplifying things. Well, your day has come. We're starting a brand new unit. I call this unit E, but it's the sum and difference identities, half angle and double angle identities. And the basics of this are, can you use a formula? If you can use a formula, you're going to do fine in this unit. I also gave you a sheet that you can use on the test, the very first sheet of your notes. Today we're going to talk about the sum and difference identities, and they look monstrous, but they're very easy once you get the pattern down. The objective is to use the sum and difference formulas to simplify trig expressions. So let's get going. First off, this chart that you have on the front, and on the front of your notes you have the chart and all of the formulas here. So what you're going to be able to do is use this on the test. You're going to be able to use this paper on the test. And I know I'm just being so soft, but I don't expect you to memorize these because they are big, long, honkin' formulas. This chart, if you know how to fill it in, or if you have that detailed chart from before, you can also use that. It might be a good time to pull it out. I believe that was unit B or C that you had the chart with all the exact values in. But here we go. I'm just going to go ahead and fill this in for you. Theta and radians for 0, 0. Sine of 0, 0. Cosine's 1 and tangent 0. For 30, that's pi over 6. Remember, pi radians is 180 degrees. 180 over 6 is 30. Sine of 30 is 1/2. Sine and cosine is square root of 3 over 2. Tangent is square root of 3 over 3. 45 is pi over 4. Sine is square root of 2 over 2, as is the cosine, because remember, equal legs. And tangent is 1. Cosine, or 60 degrees, is pi over 3. Sine is square root of 3 over 2 and 1/2. And then the tangent is the square root of 3. 90 degrees is pi over 2. 1, 0, undefined. 180, these are your quadrantal angles, pi. So you got 0, -1, and 0. 270 is 3 pi over 2. -1, 0, and undefined. 360, 2 pi, 0, 1, 0, that's the same as 0. And now you've got your chart filled in. You're going to need this. Here are the sum and difference formulas. Dun, dun, dun. Don't they look crazy? But it's really not too bad when you look at it. If you look at the pattern, you got sine of alpha plus beta, sine, cosine, cosine, sine. And notice you've got the alpha and the alpha. So you'd need the sine of alpha and the cosine of alpha of the angle to figure this out. So it kind of flips around. There is a pattern to it, but like I said, don't need to memorize them. Have to be able to recognize them. Why in the heck would we use these instead of a calculator, you might ask? To find the exact values of trigonometric ratios. All math people get jazzed when we don't have to round. We want the exact value, not the rounded value. We get all tripped out by rounding our decimals because we lose accuracy. Here's your strategy. You want to write the given angle as a sum or difference of the special angles. Special angles were the ones that we just filled in, that we know the values for. They could also be, for example, the 135 degrees because the reference angle is 45 degrees. So let's get started. Write cosine and sum difference identities to simplify or find. Now you have the ones right in front of you, the sum and difference identities. And if you look at cosine of A plus B, all they're trying to do is get you to practice filling in these formulas. So we're going to let this be our alpha, this be our beta, and I color coordinated them, so hopefully you can see the difference. The cosine of alpha plus beta is cosine, cosine, sine, sine, and a minus in the middle. And then you put your formula, your angles. So this instead of alpha would be A. Instead of beta, so A goes here and here. And instead of beta, you've got B, B, but they look very similar, don't they? They could be twins. So there's your formula. That's it. All they're trying to get you to do is learn about the formulas. So let's say instead of having an A and a B, we have a 45 degrees and a 30 degrees. We do the same type of thing. This is your alpha, this is your beta. Or you could think of it as your A or your B. So now we're going to put those in the same pattern. And I like to do cosine, cosine, minus sine, sine, and then put the stuff in. So 45 goes here and here, and 30 is going to go here and here. Alrighty. Because these are special angles, we know the exact values for them. The cosine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. And the sine of 45 is square root of 2 over 2. And the sine of 30 is a half. So when you simplify this down, square root of 2 times square root of 3, you just multiply the 2 times the 3. It's the square root of 6. Remember to multiply your denominator. 2 times 2 is 4. Then you've got over here, square root of 2 times 1, that's square root of 2, and 2 times 2 is 4. Can you subtract square root of 6 minus square root of 2? No. You could multiply them, but you cannot subtract them. That's a horse of a different color. So you leave it just like that. And that is the exact value for the cosine of 75 degrees. Exciting, isn't it? I know, it's thrilling. So we don't have to even put the squiggly, because this is the value. Let's look at this next one. Here they get fancy with the radians, but you know what these are. 3 pi over 2, that's 270 degrees. So here's my alpha, here's my beta, and it's cosine of this minus pi over 6, so you make sure you have the right formula. So it's cosine cosine plus sine sine. Everywhere there was an alpha, we put a 3 pi over 2. Everywhere there was a beta, we put a pi over 6. 3 pi over 2, 3 pi over 2. Pi over 6, pi over 6. Then the cool part comes because the cosine of 3 pi over 2, well, okay, I'm going to do the cosine of pi over 6, that's square root of 3 over 2. Sine of 3 pi over 2 is negative 1. I know the cosine of this guy is 0, and the sine of pi over 6 is a half. You don't have to do it in that order, but, you know, you look up those exact values. 0 times anything is 0, so we end up with negative 1/2. Bada boom, that's the exact value. Which should make sense if you actually simplified these fractions. This is 9 pi over 6 minus pi over 6, which is 8 pi over 6, which is 4 pi over 3, which has a reference angle of 60 degrees, but it's in that one quadrant where the cosine is negative. Alright, cosine of 195. This one, when you have to evaluate these, you have to pick special angles. So you have to kind of think, which angles would get me close to 195, or not close to, would add up to 195 that I know the exact sine cosine for. And you have more than one possibility. I chose 60 and 135 because 60 I know the sine and cosine exactly. 135 has a reference angle of 45, so I just have to watch the signs on that. It's got the same sine and cosine as 45, but since it is in the second quadrant, the cosine is negative. Alright, so if we do this, we're going to have cosine, cosine, sine, sine. Cosine of 60 times the cosine of 135 minus, that's the formula, sine 60, sine 135. And we know, since the reference angle is 45, cosine and sine of 135 is square root of 3 over 2, but the cosine is negative because 135 is in the second quadrant. So if we look at this, we're going to have 1/2 for cosine of 60 times negative square root of 2 over 2 for the 135 minus square root of 3 over 2 for the sine of 60 and square root of 2 over 2 for the sine of 135. Then you just have to simplify. So 1 times negative square root of 2 is negative square root of 2. 2 times 2 is 4. And so we'll have that. And then square root of 3 times square root of 2 is square root of 6 over 4. And then we can combine it as one fraction. So we'd have negative square root of 2 minus square root of 6 all divided by 4. Bada boom, bada bing. There it is. So cosine of 135, we already know this one. It was negative square root of 2 over 2. We didn't need a formula. But if you wanted to use a formula, if you wanted to split it apart, you'd have to kind of think about this. I'd use 45 and 90 and split it apart. You might want to try that, 45 plus 90. I usually do the addition ones. You could also use the subtraction ones. I don't know. I'm a positive person, so I like addition. Here's the second formula, sine of 60 degrees minus 45 degrees. So we're going to be finding the sine of 15 degrees exactly. So that's going to be my alpha, that's going to be my beta, and my formula for sine of alpha minus beta is sine cosine minus cosine sine. Then I put in my angles. So I'm going to have 60 for the first two and 45 for the second two. All right, sine of 60 is going to be square root of 3 over 2. Cosine of 60 is a half. Cosine of 45 is square root of 2 over 2. So is the sine of 45. Then all you do is simplify. Square root of 3 times square root of 2 is square root of 6 over 4. And 1/2 times square root of 2 over 2 is square root of 2 over 4. And that's square root of 6 minus square root of 2 over 4. Getting a lot of the same kind of values, aren't we? Let's try this one. Now, we haven't done the tangent formula yet, but oh, it's going to involve one of your favorite things, fractions. And we're even going to have fractions within fractions. So let's go ahead and label this. We know our A is going to be pi over 4. Our B is going to be pi over 6. So we're going to plug it into that tangent formula. So it's tangent of pi over 4 minus tangent of pi over 6, all divided by 1 plus. Don't forget the plus in there. I don't know why people drop that. This is 1 plus this product. Tangent of pi over 4 times tangent of pi over 6. When we do this, do it carefully, little by little. Tangent of pi over 4 is 1. Tangent of pi over 6 is square root of 3 over 3, all divided by 1 plus, it's going to be square root of 3 over 3. So we have this. We don't like the fractions within a fraction. It is no good. So we need to rationalize this. Well, in addition to rationalizing, let's get rid of the dividing by 3 on these two. So what I'm going to do is multiply the whole numerator by 3 and the whole denominator by 3. So if I do that, I end up with 3 minus square root of 3 over 3 plus square root of 3. They're still not happy. They don't like the square root in the bottom. So to rationalize it, we have to recall our difference of squares. A plus b times a minus b gives us a squared minus b squared. So that's what we're going to do here. We're going to multiply by the conjugate. So to rationalize, you're going to multiply the conjugate of your denominator, which is 3 minus square root of 3. So I multiply the denominator times 3 minus square root of 3, and I multiply the numerator by the same thing, because that's this over this is 1. If I do that out, FOIL your top. So, well, the reason I did 3 plus square root of 3 times 3 minus square root of 3 was to get 9 minus 3. And then on the top, we have to FOIL it out. 3 times 3 is 9. And then you do the outer and the inner, which is minus 3 square root of 3, minus 3 square root of 3, which gives you minus 6 square root of 3. Then you've got a minus square root of 3 times a minus square root of 3, which is a plus 3. All divided. That's the top, that's the bottom, then you simplify it. So bada boom, bada bing, we got 12 minus 6 square root of 3, all divided by 6. Since 6 goes into both terms on the top, we can simplify it further to 2 minus square root of 3. 6 goes into 12 twice, 6 goes into 6 square root of 3, the 6's would cancel. And that's your final answer. And that is all I'm going to do today. So we'll hit part 2 in the next video. See you later.